Hello, everyone. Welcome back to the channel where we review the Safety Technology Trainee Guide textbook. So today in this video, we are going to cover Module 6, 7, and 8. And let's dive deeper into Module 6. So this module discusses the use of pre-bid checklists to identify hazards that develop a site-specific safety plan. It explains the importance of an emergency action plan and covers the basic components of a safety program. Several regulatory requirements relevant to the construction industry are identified and described. And the module ID is 75222. So there are 4 sections in this module, and let's start with section 1. So section 1 is pre-bid safety planning. And after completing this section, you'll be able to explain how to use existing pre-bid planning checklists to identify specific job hazards and requirements, and describe how to use a risk assessment matrix to determine the risk of a given situation, describe how to modify an existing site safety plan to meet specific job requirements, and to list the requirements of a site-specific safety program. So let's go over a few trade terms here. Contractor pre-qualification or pre-qual, a process of screening contractors to allow them to bid on jobs for a specific company. Pre-bid checklist, a list of questions or issues that aids contractors in gathering the information needed to prepare a bid package. Probability of occurrence, the likelihood that a specific event will occur, usually expressed as the ratio of the number of actual occurrences to the number of possible occurrences. Risk assessment, the process of qualifying or ranking hazards given their probability and consequences. Then let's talk about section 2, which is all about the emergency action plans. So the objective is to explain how to develop an emergency action plan, to identify the elements of an emergency action plan, describe how to plan for specific types of emergencies, and describe how to communicate with traditional and social media during an emergency. There are a few terms here, the trade terms. So the first one is defibrillator, and that is an electronic device that administers an electric shock of preset voltage to the heart through the chest wall in an attempt to restore the normal rhythm of the heart during ventricular fibrillation. IDLH, or immediately dangerous to life or health. That is a situation that poses a threat of exposure to airborne contaminants when that exposure is likely to cause death or immediate or delayed permanent adverse health effects or prevent escape from such an environment. Intrinsically safe, an electric tool or device that is UL rated to be explosion proof under normal use. For example, a fuel pump must be intrinsically safe to prevent explosions sparked by static electricity. Universal precautions, a set of precautions designed to prevent transmission of human immunodeficiency virus or HIV, hepatitis B virus or HBV, and other blood-borne pathogens when providing first aid or healthcare. Under universal precautions, blood and certain body fluids of all patients are considered potentially infectious for HIV, HBV, and other blood-borne pathogens. Let's talk about section 3. So Section 3 covers the site safety plan, and the objective is to identify the basic components of a safety program, to identify essential safety program policies and procedures, identify effective practices for providing safety orientation and training. And there is one trade term here, and that is PSM, or Process Safety Management. And that is the process safety management of highly hazardous chemicals, or 29 CFR 1910.119, an OSHA standard that covers certain chemical plants and refineries. And we are getting to section 4, that is the last section of module 6, and that is the regulatory requirements. So the objective is to identify regulatory requirements such as OSHA, or Occupational Safe and Health Administration requirements, then EPA, or Environmental Protection Agency requirements, then DOT, or Department of Transportation requirements, and other regulatory requirements. So that was section 4, and that concludes our module 6. So as a summary, the site-specific safety plans must be customized for each project. These plans should be compiled from pre-bid job checklists and existing safety programs. The safety technician must analyze hazards for both probability and consequences, then tailor the site safety plan to minimize or eliminate these hazards through standard hazard control measures. It's important for an emergency action plan to be detailed and comprehensive. Lives can depend on that. And in addition, certain aspects of site safety management, such as traffic control and emergency procedures, should be done cooperatively. Coordinate your site safety plan with the plans of other contractors who will be working on the site. And let us move to Module 7, and the module ID is 75223. And this model describes how to prepare and deliver effective safety training, using both formal safety meetings and toolbox or tailgate talks. So there are 2 sections here, and the first one is conducting a safety training program. And the objective of this section is to explain how to conduct a safety training program, including the types of training, and then training methods, and the preparation and delivery of the safety training sessions. A few trade terms to know. So the first one is ABCD method, and that's a device used to write training objectives that specifically cover the audience, behavior, conditions, and minimum degree of mastery. So A is for audience, B is for behavior, C conditions, and D is for the minimum degree of mastery. Know, show, do. And that is a method of teaching tasks or procedures in which the instructor first explains necessary background information, then demonstrates the task or procedure, and then concludes by having the participants practice the task or procedure. Prerequisite training. Prerequisite training is the training that provides the skills and knowledge required for a course that is to follow. Remedial training. Training that is designed to address specific areas of difficulty, allowing participants to learn more about a larger course or topic. Simulators. Teaching aids that are used to simulate a piece of equipment for training purposes rather than conducting training on the actual equipment. What, why, how? And that is a teaching method in which the instructor describes what an object, task, or procedure is, why it is used or done, and how to use or do it. And we are getting to section 2, and that is the introduction to safety meetings. And the objective of this section is to explain how to conduct a safety meeting and how to deliver and document a formal safety meeting and how to perform a toolbox or tailgate safety talk. So the trade terms are as follows: audiovisual materials, materials such as photos, films, charts, and graphs that are designed to aid in learning or teaching by making use of both hearing and sight. 5 Ps for successful safety talks. And those are that is the technique for conducting effective safety talks involving 5 key elements: preparing, pinpointing, personalizing, picturing, and prescribing. Open-ended questions. Those are the questions that require more than a yes or no answer. These types of questions are used to encourage the audience to participate in the discussion. Recordable incident rate, an equation that calculates the number of job-related injuries and illnesses or lost workdays per 200,000 hours of exposure on a construction site. And this concludes our module 7. So the safety training is a fundamental requirement for ensuring that workers have the necessary safety skills and knowledge to perform their jobs safely. Proper information and planning ensures that the safety training program implementation and course delivery are done in an effective manner. A comprehensive safety training program needs to address the various types of training, including new employees, site-specific, craft-specific, supervisory, and continuing education training needs. Mentoring programs can also be used to support the safety program training initiatives. Proper use of audiovisual training aids is another important aspect of the training program that should not be overlooked. Preparation and delivering of safety training includes coordinating arrangements, preparing to train, delivering the training, managing the classroom, and concluding the training. The overall goal is to ensure participants leave the safety training with a sense of confidence that they have the knowledge and skills to perform their job safely. Safety meetings help to ensure workers are trained on how to work safely. They also provide an outlet and an opportunity for workers to share safety concerns, participate in the solutions that correct workplace hazards, and provide feedback about the training they receive. Safety meetings provide safety technicians with opportunities to learn and improve on both the content and delivery of safety topics that address the specific needs of the workplace. Safety technicians are typically responsible for coordinating and conducting all safety meetings, with the exception of toolbox or tailgate safety talks. These short, informal meetings are usually conducted by a crew's first-line supervisor. Safety technicians must know how to prepare, conduct, and record formal safety meetings. In addition, it is important to provide guidance to the supervisor on how to conduct effective and successful safety talks using appropriate resources. So that concludes our module 7, and we're moving to module 8, and the module ID is 75224. This module provides an overview of the various work permits that are typically required on a construction site. It explains how to complete a hot work permit and confined space entry permits, and describes lockout, tagout procedures. So there are 3 sections here. The section 1 is issuing work permits. And the objective is to explain how to issue various types of work permits, how to complete a hot work permit, how to use lockout and tagout devices, how to list the requirements for excavations, how to identify types of chemical hazards, and other types of work permits. So there are a few trade terms associated with this section. The first one is affected employees, and that is used in reference to lockout, tagout policies and procedures. Affected employees are usually the equipment users or operators who must be able to recognize when a control procedure is in place. They also need to understand that they're not to remove the lockout, tagout, or LOTO device or try to start the equipment during a control procedure. Atmosphere, the air or climate inside a specific place. Authorized employees, used in reference to LOTO policies and procedures. Authorized employees perform the actual servicing or maintenance on the equipment. These workers need a high degree of training. They also need to know about the type and magnitude of the hazardous energy involved and how to safely isolate and control the energy source. Competent person. According to OSHA, a person who is capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has authorization to take prompt corrective measures to eliminate them. That's the competent person. Confined space, and that is a workplace that has a configuration that hinders the activities of employees who must enter, work in, and exit the space. Energy control procedures. Written documents containing information that authorized workers need to know in order to safely control energy while servicing or maintaining equipment or machinery, also called lockout tagout procedures or LOTO. Energy isolating devices are devices that physically prevent the transmission or release of energy. Excavation, any man-made cut, cavity, trench, or depression in the Earth's surface formed by earth removal. Fire watch, assigning trained personnel to watch for fires during welding and cutting operations, sound the alarm in the event of a fire, and extinguish any fires within the capacity of the available equipment. A fire watch must be maintained for at least 1/2 hour after completion of welding or cutting operations. Hot work, any work function that involves ignition or combustion. Examples include welding, burning, cutting, and riveting. Intrinsically safe, an electric tool or device that is UL rated to be explosion proof under normal use. Lockout, the placement of lockout devices on an energy isolating device in accordance with established procedures. The lockout device is intended to use a positive means, such as a lock, to secure the energy isolating device in the off or safe position. Other employees, all employees who are or may be in the area where energy control procedures may be utilized. PEL, or permissible exposure limit, the limit set by OSHA as the maximum concentration of a substance that a worker can be exposed to in an 8-hour work shift. Most flammable gases have a PEL defined as 10%, while toxic gases have individual PELs. Permit required confined space, or PRCS. A confined space that has real or potential hazards, including atmospheric, physical, electrical, or mechanical hazards as defined by OSHA. Safety Data Sheet, or SDS, or sometimes it's MSDS, Material Safety Data Sheet, a form that lists the hazards, safe handling practices, and emergency control measures for a specific chemical. Tag out. The placement of tags or tag out devices on an energy isolating device in accordance with established procedures. It is intended to indicate that the energy isolating device and the equipment being controlled must not be operated until the tag out device is removed. Trench. A narrow excavation made below the surface of the ground. The depth of a trench must be greater than the width. The width, the width must not exceed 15 feet. And let's cover section 2, and that is the confined spaces. And the objective is to explain how to identify the atmospheric hazards in confined spaces, such as types of atmospheric hazards that may be present in a confined space, and describe how to perform atmospheric testing. A couple of trade terms here. Asphyxiation is the death due to lack of oxygen. Atmospheric contaminants, impurities in the air, any natural or artificial matter capable of being airborne other than water vapor or natural air, which is sufficient concentration can harm humans, animals, vegetation, or materials. Contaminants can exist in the form of liquids, solids, or gases. Engulfment. To be in an environment in which the victim is covered with a material such as sand, gravel, or grain. The end result is often death due to asphyxiation, strangulation, or crushing. Inerting. The use of an inert gas such as nitrogen to supplant a flammable gas in a confined space. LEL or LFL, lower explosive limit or lower flammable limit. The lowest concentration of air-fuel mixture at which a gas can ignite. Non-permit required confined space. A workspace free of atmospheric, physical, electrical, and mechanical hazards that could cause death or injury. Oxygen deficient atmosphere. A body of air that does not have enough oxygen to sustain normal breathing. This is usually considered to be less than 19.5% by volume. Oxygen-enriched atmosphere. A body of air that contains enough oxygen to be flammable or explosive. This is usually considered to be more than 23.5% by volume. Parts per million, or ppm. A measure of the concentration of a subsurface in a volume of air, water, or other medium. In a volume of air, it is the number of milliliters of a substance in a cubic meter of air. 1 part per million is roughly the equivalent of 2 soda cans full of gas in a house full of air. Self-contained breathing apparatus, or SCBA, and that is the device allowing an individual to breathe while in toxic or oxygen deficient atmosphere. Specific gravity. the ratio of the density of a substance to the density of a reference substance, typically water. UEL, or upper explosive limit, or UFL, or upper flammable limit. And that is the highest concentration of air-fuel mixture at which a gas can ignite. Vapor density, the relative weight of gases and vapors as compared with some specific standard, which is usually hydrogen, but may also be air. And we are about to cover section 3, and that is the last one in module 8. And that is all about confined space entry procedures. The objective is to explain how to prepare workers for confined space entry and to list the types of information required on the confined space entry permit, identify the roles and responsibilities of personnel in confined spaces, to identify and describe the types of emergency training required for workers in confined spaces. A few trade terms here. Confined space entry permit system, the written procedure for preparing and issuing permits for entry and for returning the permit required space to service after entry work is completed. Induced hazards. Those are hazards brought forward or created when people make incorrect decisions and or take incorrect actions during the construction process, such as omission of protective features, physical arrangements that cause unintentional worker contact with electrical energy, oxygen deficient hazards created at the bottom of pits, shafts, or vaults, lack of safety factors in structural strength, and flammable atmospheres. Inherent hazards. Those are hazards associated with specific types of equipment and the interactions of the equipment with the confined space. It includes hazards that cannot be eliminated without degrading the system or the equipment or making them inoperative, such as high voltage radiation generated by equipment, defective designs, omission of protective features, high or low temperatures, high noise, and high pressure vessels and lines. And that was the last section of Module 8. And as a summary, we need to understand that permits and policies used with a well-defined permit system help to support administrative requirements for preparing and issuing necessary permits. Permits and policies may need to be developed or modified to address conditional changes or for regulatory compliance. Safety technicians are responsible for auditing permit compliance to ensure that workers remain safe even when conditions change. Lockout, tagout procedures, and work permit systems are the cornerstone of an effective safety program. Permits and policies that are properly managed and maintained support compliance and promote safe working environment. Working in confined spaces poses significant safety hazard for workers. Management of activities in confined spaces is one of the safety technicians' most important duties. All personnel working in and around a confined space must take an active role in their own safety and the safety of their co-workers. Every member of the team needs to be aware of potential atmospheric hazards and the symptoms of exposure. Personnel need to know how to work processes may contribute to those hazards. Training is required before using test equipment to identify hazards. Confined spaces in which atmospheric engulfment and entrapment hazards may be present are referred to as permit-required confined spaces. As the safety technician, you may be the primary person who manages and administers confined space work permits. The air in a confined space must be tested before entry, and adequate ventilation must be established. Training must include emergency preparedness for evacuation and rescue procedures. Non-entry rescue should be used if possible. And entry rescue must only be done by personnel with the proper training and equipment. Training and practice will help to ensure that regulations are met and work is completed safely. And that is the end of Module 8, Chapter 3. And this is the end of our video. Thank you so much for watching. I'll see you in the next one.